Hi, this is Terry Bates of the Cornell Lake Erie Research and Extension Lab, and I'm going to talk a little bit about potassium deficiency. We are seeing a lot of reports coming in this season from veraison to harvest looking at what people call blackleaf and Concord vineyards. And there are different things that can cause blackleaf symptoms. One of them is potassium deficiency, and that's what I think we're seeing in our region this year. So you start to see these vineyards that have a kind of dark green and then a blackish type color all over the whole canopy. So that's where the term blackleaf comes from. And really, you're getting an interveinal chlorosis of the cells of the leaf based on potassium deficiency. And you tend to see the worst deficiency on the basal leaf. So if this shoot that grew throughout the season, if this is where it inserts into the cordon, you're going to get, in bad cases, these like crispy leaves towards the base and then black leaves symptoms in the middle of the cane, then one's followed with just some darkening around the edges in the middle, and then out towards a growing shoot tip that's also a sink for potassium. And so those tend to have more potassium in it and will stay green. And what's happening, because it's happening between veraison and harvest, it's that the fruit from veraison to harvest requires a lot of potassium in Concord, and especially when we're running big crops, that the larger the crop, the larger the potassium demand by the crop, and it'll take it out of the vegetative structures of the vine, so you start to see the black leaf symptom. Okay, so how can we prevent this? How can we work with it in our vineyard so that this sort of thing doesn't happen? I have a whole presentation on potassium and its role in the plant and potassium deficiency, and we look at how potassium goes in the soil and in the roots and in the plant demand, and then its role in fruit development. So this is a really long talk, but I'm just going to hit a couple highlights in this blog just to see how potassium deficiency is affecting us this season in our vineyards. Okay, so the first thing we look at is potassium in soil. How does potassium go from the soil and get to our roots, and how the plant takes it up? So nutrients will get to the plant through interception or mass flow, and those are small factors when looking at nutrient uptake. For an element like potassium, the primary way that the nutrient gets to the root system and is taken up by the root is through diffusion through the soil water. So in between soil particles and other things that are in the soil, there's water, and nutrient ions will float through that water. They'll diffuse through it to the root surface and it'll be taken up by the root. And there are things that affect that diffusion that affect nutrient uptake. So you'll have potassium that is attached, loosely associated with the soil particles, and a thing we call cation exchange capacity. The exchangeable potassium will be surrounded by water and be dissolved in the water, and then that potassium diffuses to the root system, and then it can be taken up by the plant. So how do we influence that through our management in the vineyard? Well, we have to understand what is affecting that diffusion or diffusion coefficient of potassium within the soil. And some things that we can affect, like how much water is in the soil, or the concentration of potassium in the soil solution through fertilizer application, or the amount of exchangeable potassium from the solid phase. And mainly that's through being able to control our soil pH and our cation exchange capacity and how many ions and different positively charged ions are in the soil. I'll explain that in a second. So let's look at water first. So we look at percent soil moisture in the soil throughout the growing season, and the available water for the plant and for the diffusion of those nutrients through the water will change depending on your soil type. So if you have a Shenango gravel loam, it's going to be somewhere in this sandy loam. If you have a Niagara silt clay loam, it's going to be more like this one here. So what does that mean? Okay, let's take a loam soil at field capacity. So it rains and then the soil drains, and what's kind of the water that's left there is called field capacity. And that's somewhere around 35%, and then that soil may dry down to about 15%. And if it goes below 15%, then that water cannot be extracted by the roots anymore, and the plant starts to wilt. In terms of nutrients, as this soil starts to dry down, it becomes more and more difficult for ions like potassium to diffuse through the soil water to the root system. So part of nutrient management is being able to maintain adequate soil water so that those nutrients can get to the root system. Another big thing is being able to supply potassium, magnesium, and calcium to the vine, and we do that by having those cations attached to the negative surface charges of soil. So we call cation exchange capacity, and soils have different net negative charge, different levels of net negative charge, which changes the cation exchange capacity. So here are some situations that actually have vineyard implications. We have soils with low CEC, so a very sandy, gravelly soil is going to have low CEC, so it's going to have low nutrient holding capacity all the way around. You may have to help those soils out with some supplemental fertilizer applications like potash. We also have soils that may have a higher CEC but are acidic, meaning the soil pH is low. If the soil pH is below 5.2, the solubility of aluminum in the soil, it becomes much greater, and that occupies all the exchange sites. So the positively charged, the good ions, potassium, magnesium, calcium, get leached out of the soil and won't be there for the plants to take up. So our rule of thumb is that I want to apply 2 tons of lime per acre per year in established vineyards until the soil pH is between 5 and 6. It is critical to get the soil pH above 5.2, and so we set the zone between 5 and 6. I even like to say 5 to 6.5 is okay. So what's wrong with going all the way up to 6.5 or 7? There's actually nothing really that wrong with it. What happens is when the soil pH goes up, you get aluminum comes out of the equation, so now all the exchange sites can be satisfied by calcium, magnesium, and potassium. But what happens is the higher the soil pH goes, the higher the calcium and magnesium go, and especially magnesium starts to outcompete potassium. So if we continually put down lime to raise our soil pH and make the nutrient balance in the soil more favorable for the plant, we start to run into a competition between magnesium and potassium. So we just help out potassium a little bit by adding some potassium fertilizer so that it can stay in competition with magnesium for both exchange sites onto the soil and then uptake into the plant. And so what do I mean by that? If we look at the root system of our grapevines, that we talk about surface area, the greater the surface area of the root system, the greater the nutrient uptake, the lower the surface area of the system, the lower the uptake. So things like phylloxera and nematodes and low soil pH, which can inhibit root growth, will actually decrease the amount of nutrient uptake, but anything that increases our surface area of the growing root system, so a benign environment for growing roots, just make the soil chemistry and water optimum for your root system, they're going to grow more roots and you're going to take up nutrients. So where does the competition between potassium and magnesium come from? So as potassium and magnesium flow to the root system, and the root system is going to take it up, it's got to cross membranes in the root system or in the root cells. And when you have to cross a membrane, you can regulate it. So just like a bouncer standing at the door of a bar, you're going to let in some things and not let in other things. Well, there are transport proteins within the cells of the root systems, and transport proteins for potassium and magnesium are no different. You have proteins, they are selective in what they take up, and this is where you get some competition between potassium and magnesium, and you may want to add some potassium fertilizer to help outcompete magnesium. The old saying is that we'd like to see a little, if I had to see a deficiency, I'd rather see a little magnesium deficiency than potassium deficiency, because the fruit takes a lot of potassium out of the vine, and if you run into potassium deficiency, you can see a major hit to vine size for the next growing season. And that's a big concern for us because vine size is equal to production. So we've done studies where we've dug vines out of the ground throughout the season, measured all the different parts for their nutrient holding capacity. And the one thing I want to point out, between veraison and harvest, about half of the potassium that is in the vine is in the fruit. So the fruit is a very strong sink. The larger the crops that we're growing, the higher the potassium demand is going to be. And so if you are in years where you're expecting a very big crop, you really want to have a little supplemental potassium fertilizer on there so that the vine doesn't become deficient. I just wanted to show one thing here, that in an annual cycle, we need, in vineyards where we're growing big crops, 8 to 10 tons per acre, we need about as much potassium as we do nitrogen. So that's something that we need to be concerned with. We take soil and petiole tests to look at the nutrient status of both the soil and the vine, and we have recommends. So if you talk to your extension agent, there shouldn't be any real question. If my values are telling me one thing and say it's a dry year and a big crop, and those are the kind of conditions you want to be putting on potassium fertilizer. So we have recommends, and they're there. And you can talk to us here at the Cornell Lake Erie Research and Extension Lab to get those kind of recommends. And all of that science goes into trying to prevent this black leaf symptom from veraison to harvest. If you have any questions, you can always stop in at the lab or comment in the website below. Thank you very much.